The second part of our lesson today in section 8.1 on the back side deals with evaluating. Remember, evaluating means you're going to plug it in using parentheses. So just a reminder, always use parentheses when you evaluate and plug in. So let's look at our first one. Our hint at the top says when you evaluate, you can write the expressions with positive exponents before you substitute in the values. This will make your life a whole lot easier. Now, what are our values that we're going to be plugging in later? -3 and 5. So let's look at what we have here. X to the -3. As we did on the front page, let's write that with positive exponents before we start. Well, that's 1 over x cubed. Now let's replace that x with the value of x in our problem. Well, what does x equal? It equals -3. So I have to think to myself, what is -3 times -3 times -3? Well, that's 1 over -27. And as we've learned, we can never have a negative exponent or a negative number in the bottom. So we're going to put that negative sign out front and have -1 over 27. Let's look at our second one. Once again, let's simplify before we plug in our numbers. Y to the 0. Well, from the front page, we remember anything to the 0 equals 1. Well, we can't plug anything in because there are no variables, so that's our answer. That was pretty easy. Our third one, 3x to the -2. The 3 doesn't have an exponent. It stays on the top. The x does, so it goes to the bottom and becomes positive. So now we say, let's plug in. Well, what are we going to plug in for? We're going to plug in for that x value. So I put my parentheses and I plug in. What do I plug in? A -3. Well, -3 times -3 is 9. And that's going to simplify to 1/3. Fairly straightforward as we look at that problem. Moving down, let's look at D. Our positive exponents are 5 to the first and x squared. Our negative exponents are y squared. So the y squared goes to the bottom. Now let's plug things in. For x and y, once again, we're going to put in parentheses. In place of the x, we put a -3. In place of the y, we put a 5. Let's try to evaluate this. That's 5 times 9 over 25. I could use my calculator to simplify this, or I could just do a canceling. 1 and 25 cancel to 1 and 5, and so my answer is 9 over 5. Our final problem of this section, we have 2 problems with negative exponents and 1 without. So the x squared doesn't have a negative exponent, it stays on the top. The 2 squared and the y squared go to the bottom and become positive. Now let's plug things in. I'm going to change the 2 squared to a 4 while I do this and leave my parentheses open. I replace my parentheses with the values of x and y up top, which are -3 and +5. -3 squared is 9. 5 squared is 25. Well, 9 times 25, or 9 over 4 times 25 becomes 9 over 100. So there's our answer. Our final part of this section deals with writing numbers as powers of 10. Well, a power of 10 can be thought of as counting up the number of zeros. 10 is 1 power of 0. 100 is 2. So 1,000 is 3 powers of 0. So this is 1 over 10 cubed. Well, how do we handle that? How do we make an exponent that's positive in the bottom as a power of 10? Well, we just bring it to the top and make it negative. And since they wanted to write it as a power of 10, that's 10 to the -3. Let's count up the zeros in the next one. 1, 2, 3, 4, 5. So that's 1 over 10 to the 5th. So that's 10 to the -5 in the numerator. So there's an example of how do we write 1 1,000th as 10 to the -3. On the other side, we're asked to write things as decimals. Well, the number of decimal places has to do with the number of exponents. So this has 5 exponents. So we're going to go 1, 2, 3, 4, 5. In those 5 blanks, we're going to have to create the number that will be represented by 5 to the negative, or 10 to the -5. So let's talk about what this number is. That's tenths, hundredths, thousandths, 10,000ths, 100,000ths. So this is 1/100,000th. Our last problem here is a 10 to the negative 3. So we have 3 blanks for our decimals. So that's going to be 1,000th as a number. So as we talk about our decimals, we're going to write the number of blank spaces representing the number of decimals that corresponds with our exponent.